Lesson 2.3 on the quotient rule. We've got some notes already kind of queued up here on the quotient rule, and you might want to go ahead and write this down. And the quotient rule is basically the opposite of the product rule. With the product rule, we added everything, right? We added the exponents of like bases. But when it comes to quotient rule, quotient represents division. You know, we're dealing with fractions or ratios. And when it comes to these problems, the quotient rule tells us to subtract, or in other words, find the difference of the exponents with like bases, of course. So that is what we're going to do. So for number one, and you don't have to do it this way every time, but I just want to show you what's going on here. For number one, we're going to do 7 to the power of, and you don't have to put a parentheses, but I'm going to do that, 4 minus 2. So we're going to subtract those exponents, and that math itself is not crazy. And then 7 squared, that equals 14, right? No, it doesn't. Equals 49. Equals 49. That's it. Okay. So for number 2, we're going to do that. So we're going to do n, and then for that we're going to do the power of 12 minus 4. That's what we're going to do. So 12 minus 4. Get your calculator out for that one. No, you don't need a calculator, do you? Hopefully you don't need a calculator for that. But 12 minus 4 is 8. That's all you can do. All right. For number 3. All right. I want to look at this a couple different ways. So one way to look at this is just like we have been as exponents and using the quotient rule, which means we need to subtract. So what we're going to do is we're going to do 2, and then we're going to do 1 minus, and then notice this is already negative. So if I just do 1 minus 3, I'm not really following along with that negative exponent that's already there. So I need to do 1 minus negative 3. You didn't have to put parentheses there, but I just want to show you that we have a minus situation right there. You have minus a negative, which means plus. That's what's going on there. So you got 2 to the 1 plus 3 power, which makes 2 to the 4th. I know I'm like making this longer than it needs to be, but just kind of showing you what's happening here mathematically. And then 2 to the 4th power equals 16. Okay, so that's one way we could have dealt with that problem, which I don't think is too difficult. And then another way to deal with it is to kind of just think about the way negative exponents work, which is that you can change their position and change their overall position. So we can move that up. So now what we have is you have 2 to the 1st power. I'm going to write a little dot for multiplication. Looks like exclamation, doesn't it? Put it right over there. There you go. And the times 2 to the 3rd. Okay, because we moved. We don't really need that denominator anymore, but there's a 1 there if you want to think of it that way. But you know, same thing happened on this one. So you got 1 plus 3. We can just use product rule, which makes 4. 2 to the 4th power, and that still makes 16. No matter which way you cut it, you still get the same answer. All right, for number 4, if we do this one, we're going to have x to the 3 minus 5 power. Now 3 minus 5, this is our first example where we end up getting a negative exponent. So you get x to the negative 2, and we don't want to leave anything with a negative exponent unless it's explicitly saying so. But in this case, we don't want to leave it that way. So we're going to change the negative 2 to positive 2 by changing its location. So this is going to become 1 over x squared. 1 over x squared. All right. Now for number 5, it's very tempting to subtract the 3 and the 2, to subtract those exponents, but we're not. We cannot do that. Do you know why? You know why? Think about it for a second. Why do you think? The reason why is because they're not like bases. We have a 4 here and we have a 5 there. So they're not exactly the same base. They're totally different. So we're just going to work those out separately. So 4 to the third power equals 64 and 5 squared equals 25. And that's it for number 5. Number 6, we've got negative exponents. Now, here's another way we can kind of deal with this one, which is the way we've always been dealing with negative exponents, which is move their position and make them positive. All right, so you can do that. So now we have v to the positive 5 power in the numerator, and we have v cubed that went down to the denominator. And then apply the quotient rule, which is subtraction. 5 minus 3 is pretty simple. That's 2. So you got v squared. That's it for number 6. All right, on this page right here, there's a little bit more to these, maybe a little bit more simplification that we need to do, but same thing is going on. For number 7, let's take care of this negative exponent and move that down to the denominator. So I'm going to leave the -2 coefficient there. R to the 10th is not changed as of right now. And then R to the -3 moved down to the denominator, making it +3. So now you have R to the 10th, R to the 3rd. And now let's apply the product rule, which is just, we're going to add the exponents. So you got R to the 13th. All right, for number 8, it doesn't hurt to, when a base doesn't have an exponent, it doesn't hurt to just kind of put a 1 there, just so that you have something to kind of work with. You don't have to, but now we can apply the quotient rule. So we're going to do for the F, we're going to do 4 minus 1. And for the G, we're going to do 11 minus 3. See what I mean? And so that's not too crazy. We got F to the F cubed, and then G to the 8th power. That's it for number 8. All right, for number 9, now this is our first example here where we have some simplification that can go on with the coefficients. And so you got 16 and 6 right here, meaning that you can divide those by a common factor. Now, the greatest common factor of 16 and 6 is 2. So you divide that by 2, that becomes an 8. You divide the 6 by 2, that becomes a 3. Okay, so we took care of those. And then the next thing you might want to do is let's clean up those negative exponents. Let's simplify those. Let's make them positive. So let's just flop those positions there we have for those terms. So I'm going to go ahead and do a rewrite here. We've got, we've got 8, and then the P came upstairs, and now it's Q to the 4th. That was always there. And then there was a 3, and the P that was on top, that was -6, came down to the denominator, became +6, and then the Q cubed. All right, so when it comes to the 8 and the 3, we can't do anything else with that, but we can do something with the variables. So what we're going to do is, and here's the thing too, like, if we focus in on this part right here, we have P squared and we have P to the -6. One thing that's worth pointing out is that there are more P's. You want to look at where there are more P's, and there are more P's in the denominator at the bottom. So maybe instead of thinking of it as subtraction, think of it as a difference problem. Think of what's the difference of 2 and 6. And I know that's the same thing. Subtraction and difference is essentially the same thing, but how far is 2 from 6? Well, it's 4 away. Plus or minus doesn't matter. I'm just saying it's 4 away. So what that's telling us is that there are 4 more P's in the denominator. So that's kind of telling you where they should stay. If there's more p's in the numerator, then you would leave them there. If there's more p's in the denominator, like in this example, we leave them there. Okay. And then as for the q's, there are more q's. There's just one more q in the numerator than there was in the denominator. So q to the first, but we don't need to put that one there. When it's just the one, just leave it as q. It's implied. We know that it's there. You don't need to show it. All right, on the last example for this one, we have we have coefficients again that could be simplified. Now 30 and 48 have a GCF of 6. So when you divide that by 6, you get 5. And when you divide 48 by 6, you get 8. So you get that. All right, now I have a b as well that needs to move. So that's what I'm going to do. Okay, when I do this, I try not to do too much at once. So I've got 5a squared. In the denominator, we've got 8, a to the 4th, b to the 4th, and b to the 6th. And the b to the 6th came from moving the -6 power down. And the only thing that we can do is use product rule. Use a product rule with these two powers. We've got b to the 4th, b to the 6th, which makes b to the 10th. And now let's put it all together. So we've got 5a squared over 8. Oh, I didn't finish it. Let me do this. Forgot about the a's for some reason, but let's go ahead and take care of those too. So we have 2 a's in the top and we have 4 a's in the bottom. So where are they going to stay? They're going to stay in the bottom. They're going to stay in the bottom. So there's nothing left letter-wise in the numerator. There is a coefficient. There's a number. We have a 5. But we don't need that. We don't need any letters up there. So now we have a squared and then b to the 10th. There we go. That's a little easier to work out. Okay, that concludes this lesson on, what was it, 2.3, quotient rule.